Hello everyone, I am Mageshwari, Assistant Professor, Department of BSc Information Technology at Dr. SNS Rajalakshmi College of Arts and Science. Now I am going to explain my lecture video about memory management system in operating system. Memory management is a technique which helps to manage the memory and utilized by the various different kinds of processes by properly. This is the very important technique. This can be handled by operating system in order to rectify the process handling techniques. In memory management, it is a key functions of operating system that handles allocation and deallocation of memory space to the program or processes. There exist various techniques which can be helps for memory management. The techniques are nothing but paging, segmentation, and then contiguous memory allocation. These are all the technique which helps to utilize the memory properly. These are all the technique handled by the operating system in order to utilize the memory space properly by executed processes. There exists very importance over the memory management techniques. It ensures efficient utilization of computer's memory. It prevents conflicts and overlaps between the processes, improves system performance and stability. The key functions of memory management are nothing but it keeps tracks of that means records of memory usages. Allocation, it is nothing but assigns the memory space to the programs or process in order to store and execute. Deallocation, once the process has been completed its task from the OS, it frees the memory after its execution for further usage. Swapping, it is another method that it helps to move a process or program from the main memory to the secondary memory or secondary memory to the main memory. This process we call it as swap in and swap out. There exists a type of memory space in operating system, that is primary memory and virtual memory. In primary memory, it is nothing but it is a main memory. It is also a volatile memory. Once the power issues happens, the data will be lost. The data loss will be happen. It's a volatile and faster but limited in size. And then secondary memory, it's a non-volatile, example HDD and SDD storage, stores data and programs not in use. Virtual memory, it extends RAM using disk space, enables multitasking by swapping data between RAM and storage. And then cache memory, it's a small and high speed memory for frequently used data. In memory allocation techniques, we have a different techniques are available. The first one is nothing but contiguous memory allocation. In contiguous allocation, the memory is a single contiguous block, simple but prone to fragmentation. In contiguous memory allocation, some uniform spaces can be allotted for different kind of processes. So in this technique, there may be a chance whether the particular process can waste off the memory allotted memory space. So this is the drawback of contiguous memory allocation. And non-contiguous memory allocation, it divides the memory into fixed blocks and pagings or variable sized blocks known as segmentation. It reduces the fragmentation but also allows the better utilization. In the next allocation technique is paging. It divides the memory into a number of equal sized pages. That pages we call it into a frames. For example, if a process having of 16 kilobytes, then the memory space will be divided into equal 16 frames. In each frame, 1 KB of process will be stored and executed simultaneously. It divides the memory into equal sized pages. It maps resources and pages to the memory frames. A segmentation, it divides the memory into a logical segments. It provides a better process organization. These are all the techniques which helps to manage the memory properly. Using main memory, there are also that we have different types of addressing scheme: physical addressing and logical addressing. In logical addressing, it can be handled by operating system, and physical addressing is nothing but it has the memory address provided for storing the process or either a program. In this physical address, different ID can be allotted allotted for each individual process. By keeping this ID, we can verify and rectify and access that particular process or programs over the time. This memory allocation technique has some challenges and trends. In this, there exist challenges. First, fragmentation. During fragmentation, there is a chance for wastage of memory due to inefficient allocation. In fragmentation, we are dividing some space into a equal number of spaces, equal number of fragments, so that the programs may or may not use that allotted space properly. So there is a chance for wasting of memory by a particular process. And then thrashing, it's another challenge of memory management technique. During thrashing, excessive swapping causing performance degradation. And then scalability, managing memory for increasing workloads. So it provides a low scalable in that memory management technique. In future trends, by using AI-driven memory management, predictive allocation for better performance, it improved virtual memory techniques. It is a faster and more efficient swapping. Hardware advances, integration of non-volatile RAM for faster access. By using this kind of advanced techniques, we can improve our memory management technique in future partitions. Thank you.